quickly go through selecting multiple different fan coils for when you've got a large mini split job and are just trying to figure out which size needs to go in which unit to meet loads. So here I'm going to press new job. We're going to do this as plan and spec. Right now I'm actually going to default to the Mitsubishi Electric versus Train Mitsubishi model numbers due to them being easier, more familiar. Design conditions, we can either pick based on a location. So in this case, I'm going to pick Seattle, Washington. And then that will give me outdoor design conditions. My indoor design conditions in this case are going to be 78 and 62. Because that's what was requested, and I'll leave indoor heating conditions at 70. Now I'm going to press OK here. It's going to ask me to create the system. First system I'm going to select is an M series unit. And the engineer wanted a couple of MUZ GL series units. So I'll start with first the smallest one, the MUZ GL09. And then its indoor unit is selected. Given that this is going to be at the furthest away, I'm going to go ahead and put in a longer line length. And I'll put in GL09 here. So now this is going to show us what our total cooling is on this unit, our sensible, and what our heating is. So now I'm going to go ahead and add another system. And with this one, we will go with the MUZ GL12. A side note here is that this is actually, I think, a better system than the GL09 because this one actually has a much better turn down in operation. The GL09 minimum capacity is somewhere in the 3,500 BTU range. The GL12 turns down to 1,500 BTU, so it'll operate for longer without turning its compressor off. All right, I'm going to add one more, although I think both these selections go ahead and have the numbers that I needed, but we'll move up one more size to the GL15. All right. Find this, MUZ GL15. There we go. I'll double click here, GL15. And then once again, I'm going to put in the maximum line length. And this is to have our piping length D rates calculated in on our conditions. So since we've got such a low wet bulb temperature compared to our dry bulb temperature, we're having some very high sensible cooling numbers. If we were to go back into project properties, change our design conditions, and put this guy up a little bit higher, let's say 64, so we're more humid. Let's actually do it 65, just make it a bigger difference. We can now see that our sensible numbers have dropped in comparison to where they were. So that's where those calculations come into play. Okay, so this covers this. I was also asked to provide numbers for the one-way sealing cassettes. So this is also an M-series system. The SUZ is going to be the condenser that that's used for the one-way sealing cassettes. The KA09, this HZ right here, that's for the hyperheat, and our design conditions don't need that. So now, instead of auto-populating an indoor unit, because this one is the universal model, I can actually pull over different individual units. So here, I'll have the MLZ, the one-way sealing cassette. I will put the pipe length at 65 feet, which is our maximum, and there we go on that guy. So, and this one I'll just put one way and 09. So now add one more system, or probably end up doing two more. We will make the, let's grab the SUZ 12. Oh, there it is. And the 12,000 BTU one-way ceiling cassette, 65 feet. And one more system here. Oh, never mind. Apparently, I forgot the 15 is not one of the models. It's an 18 for the one-way ceiling cassette. So I'll just double click on that condenser. No need to delete that. Go up to the K18, and now I'll drag one of these guys over. So as you noticed on the previous screen, there was nothing here because there was no valid selection. So and this one can actually go to 100 feet, so I will throw that in. Now keep in mind, that is assuming no hard 90s. If I were to throw even one in there, it's going to give me an error that the piping length is too great, and that is because that adds equivalent piping length. So we'll call this one one-way 18. And you'll notice I'm doing this here instead of in the tag, because when I export the PDF for quick reference, this what's shown here is what is at what's on the centralized system, not what the actual tag of the unit is. All right, and we had a couple P-series units that needed to be added. So now I will come down and I will add a P-series. We'll start with the PUZ A12 and the wall mount for that. So that one is going to be 100 feet at its furthest. So this is going to be P-series 12, and I will add an 18 here as well. And this one is also going to be at 100 feet. I'm going to add one more P-series because in order to get extended line lengths, just in case it's necessary, even though it will be overkill for the space. So I will add an A24, which gets me 165 feet. And there's that one. So we'll do P-series 24. And I might as well, the GL18, I think, is where you get to 100 feet allowable. So I'm going to go ahead and add one of those as well. I might be wrong, but that's what we're here to check. All right, so the GL18 is up to 100 feet. So I will throw in 100 feet on there. And because that will be a less expensive unit than the 18 P series, so might be the better choice in certain sections. So this one is going to be GL18. And because I want things to be in a nice order, the newer versions of DSB actually have this nice little feature of move system up and down. I'll move that guy right up there. So now I've got everything nice and easy to look at. So this gives me all of the units that will meet or exceed the capacity numbers that we're looking for here. So if this was a project, if this was actually a project, or I wanted to have this for reference or to change it around later on, I would go File and I would save, and then I would rename it and it would actually save to the cloud account. In this case, I don't want that. So what I'm going to do is export the PDF. Oh, and it throws the issue because I need to assign controllers before it'll allow me to do that. Controls view, these guys don't have their own built-in controllers, so I'm just going to go, I'll just put an MA controller on those P-series units. Oh, undo that. And actually we'll go with the MHK2. I'll do that on all of those because these little wall remotes can sometimes walk away. So remove multiple controllers. And now I will do the MHK2 on everything. There we go. This image hasn't been updated yet, but the MHK2 is a much nicer looking thermostat than the MHK1 was, and it's compatible with M-series and P-series units, whereas the wired thermostats are only compatible with certain M-series and P-series units. The M-series wall units will require an adapter, which becomes more expensive than going with a different thermostat to begin with and more complicated on the install. Now if I go to Tools, Global Check, it will do the checks and make sure that everything's good. There we go. Now I can do my export. Export to PDF. And then I would go ahead and I just want the design view because that's going to give me this right hand bar that shows my design conditions here at the bottom, my D rates based on pipe length, based on temperature, based on defrost, maximum pipe length, everything else, and the system view that we saw as we were creating this. This is where I'm going to end the video because I don't know how this is going to look after I press OK with recording the video, since I'm recording a window and not a screen. Hopefully this was helpful and will allow you to quickly go through DSB and create your own selections in the future if you need some quick numbers on what an individual unit will be able to do. Thank you for your time.